Hello student, I hope all of you are doing well. So I am back with the solution of assignment from unit 2 which I had given to you on 27th of March. So let us discuss the very first question, which was the possible states of a d electron in one electron atomic system. So we know that the L value describes the orbit in which electron is present. So if the orbit is S, the value of L will be 0. If the orbit is P, the value of L will be 1. And if the orbit is D, the value of L will be 2. And if it is F, then it will be 3. Now, for a D orbit electron, we have the value of L equals to 2. So I have written here L is equal to 2. And for a single electron, the spin is 1 by 2. So possible value of J are L plus S2 modulus of L minus S. Please note that here the modulus is because the J value cannot be negative, because it represents the total angular momentum of an atom and it cannot be negative. So the two J values are 2 plus 1 by 2 to 2 minus 1 by 2, and they will be 5 by 2 and 3 by 2. And it also represents the multiplicity. Multiplicity is always given by 2s plus 1, and I can calculate it here also. The value of S is 1 by 2 plus 1. So this is 2. This 2 represents the total number of J values. There are 2 J values, so multiplicity is also 2. Now, a given state can be represented as by the relation 2s plus 1 L J. This is the multiplicity which is in the superscript. This is L value and this is J value. So, for J is equal to 5 by 2, the state will be multiplicity is again 2. Then what we have D electron, so it will represent a D state, and J value is 5 by 2, so state will be 2D and 5 by 2. And again for J is equal to 3 by 2, the state will be 2D 3 by 2. So the two possible state are 2D 5 by 2 and 2D 3 by 2. So in this way you can calculate the total number of possible state for any electron. It can be in S state, or it can be in P orbit, or it can be in F orbit. So this is very simple, and this is very important from examination point of view also. So let us now move to the second question. And the second question was doublet term separation for a P electron. So first of all, very first we should know that this tau values is given as, which is the doublet term separation, A dash J star square minus L star square minus S star square divided by 2. Now what is this J star square? Since J star is equal to J into J plus 1, so J star square will be J into J plus 1. And again L star square will be L into L plus 1, and S star square will be S into S plus 1. So we should know about the J value, L value and S value. And we are given a P electron. Again, I have told you that for P electron the value of L is 1. So I am again using this value over here. L is equal to 1. For a single electron, S is equal to 1 by 2, and possible J values are 1 plus 1 by 2, 1 plus 1 by 2, 2, 1 minus 1 by 2. We will get 2 J values, 3 by 2 and 1 by 2. So the terms are 2p 3 by 2. Again, as the we will use the same procedure, 2s plus 1 L value and J value. So 2s plus 1 value, again there are two states, so it will be 2. And for P electron, again it is P and J value is 3 by 2. And for this term, the possible state is 2p 1 by 2. Now for this state, I will substitute the value of L, J and S. This is my formula. I have written down it here. So tau value will be 1 by 2 A dash. Again for 2p 1 by 2 state, I will again substitute in the formula, and the term value will be, the doublet term separation will be minus A dash. So this is how you will calculate the doublet term separation. You can calculate it for D electron, F electron and so on. So this was the second question. Now let us move to the third question. Our third question is, what is spin orbit interaction? And this is very simple. This is the interaction between the spin motion and orbital motion. What happen is, the orbital motion, which is the electron is revolving in its orbit, will produce its magnetic field, and that magnetic field of orbital motion will interact with the spin of electron. So there is interaction between orbital and spin. magnetic field of orbital motion is interacting magnetically with the spin motion of electron, and this is what is known as spin orbit interaction. And you can simply write L plus S is equal to J, and I will also draw a diagram over here. This is L star, you can write, this is S star. They will interact each other and will produce J star, and they will also precess about their resultant and prescribe a cone. L will prescribe a cone, similarly S will also prescribe a cone. So this is what is known as spin orbit interaction, and this is responsible for fine structure of spectral line. This is very important. So this was the third question. Now let us move to the fourth one. The fourth question was, we have to calculate the magnitude of total angular momentum for a d electron. Now what is the value of L for a d electron? Again, this is 2, and since this is a single electron, so S will be 1 by 2. So total J values will be L plus S, 2 L minus S. So this will be 2 plus 1 by 2, 2 minus 1 by 2. We will be having two values, which is 5 by 2 and 3 by 2. Now we have to calculate magnitude. Now what is the magnitude? We know that J vector is equal to J star H cut, where J star is equal to under root J into J plus 1. So its magnitude will be J into J plus 1 H cut, and we have calculated the value of J over here. So you can use firstly J is equal to 5 by 2 and calculate the magnitude, which is 5 by 2 plus 1 H cut, it is root 35 by 2 H cut, and again you can use it for 3 by 2, and this will be root 15 by 2 H cut. So this is how we calculate the magnitude. You can also calculate the magnitude of orbital angular momentum and spin angular momentum on the same basis. So this was the fourth question. Now let us move to the fifth question. The fifth question which I asked was, what is Larmor precession? It is very simple. Whenever an atom is placed in an external magnetic field, the plane of the orbit, or you can say the normal of the orbit, will start precessing around the magnetic field, and this precession is known as Larmor precession, and the frequency with which that normal precess around the magnetic field is known as Larmor frequency. So I will draw a diagram over here. So since let us say this is the electron revolving in a particular orbit, so this, the normal to this orbit will be the orbital angular momentum vector, and let us say this is the magnetic field, this is B. So it will precess around this magnetic field, and this is known as Larmor precession. And we have also calculated Larmor frequency omega L, which was EB by 2m. It is only depending upon magnetic field. Greater will be the magnetic field, greater will be the Larmor frequency. So this. So now we will discuss the sixth question. The sixth question is, find the value of LSJ from the given terms. So first the term was 2p 3 by 2. We will compare it with the expression 2s plus 1 Lj. Let us compare this with this expression. So this is the multiplicity, which is 2s plus 1. From here you can calculate the value of s. This p is representing L value, and for p L is equal to 1, and this is simply the J value. So we will calculate L, S and J, and the rest of the terms can also be done with the same process. So this is how you can calculate L, S and J, and this is very important question from examination point of view. Now the seventh question was very simple, and it was, find the value of L for a F electron, and L is equal to 3 for F electron. I have written down all the numbers and the orbits. Now let us move to the eighth question. It was, what is multiplicity? Simply a factor 2s plus 1 or spin determines the multiplicity. It simply explains the total possible states for an electron on the basis of spin orbit interaction or total J values. This is multiplicity. So what was the ninth question? It was quantum defect. We know that for a non-penetrating orbit, the value of principal quantum number and azimuthal quantum number is almost equal for a non-penetrating orbit. But for a penetrating orbit where the electron penetrates the atomic core, there is a difference between the principal quantum number and azimuthal quantum number. They are not equal, and this difference is known as quantum defect. And the last question was why the value of k, which is the azimuthal quantum number, cannot be 0. It is very simple, because from Sommerfeld model we have a quantum condition which is p theta d theta is equal to kh. So if k is equal to 0, then p theta is equal to 0, which explains that angular momentum of electron is 0. It simply say that electron is not revolving in a circular path, it is moving in a straight line, which is not possible in case of an atom. So that is why the value of k is equal to 0 is not permitted. So this was all of your assignment of unit 2. All of this question are very important from examination point of view. So I'll suggest you that please prepare these questions on your part. Thank you so much.